Okay, in this video, we're going to look at the division of radicals. We're going to start with a couple simple, easy ones. First, you can divide a radical by a radical, but you cannot divide a plain number by a radical. So we're going to look at a radical divided by radical. So I have the square root of 12 divided by the square root of 2. Because they're both radicals, I can ignore this for right now and just do 12 divided by 2, which is 6. So my answer is the square root of 6. I'm going to keep the radical. Okay? The next one is the square root of 48 divided by the square root of 6. I'm going to give you a couple seconds to try this one on your own. Okay, if you're not ready, just go ahead and hit pause. In this case, 48 divided by 6 is the square root of 8, but I can simplify the radical 8, square root of 8, breaking it down, 4 times 2, break down the 4, 2 and 2. I have a pair of 2's, and a 2 stays home. Easy enough. Let's look at the next case. The next case, I have plain numbers and I have radicals. So I can do plain divided by plain. So I can do 6 divided by 3, which is 2. And then I can do radical divided by radical. 28 divided by 7 is the square root of 4. Now 4 is 2 and 2. So that's a pair of 2's that join this 2 that's already outside, which leaves me with 4, and nobody's left at home. So my final answer is 4. Now let me change this slightly just so you can see the difference. I could have had 6, the square root of 28, divided by 3, the square root of 4. And in this case, I would have done 6 divided by 3, which is 2. And 28 divided by 4, which is 7. 2, the square root of 7. Just another example. Okay, I'm going to give you a second to try this one on your own. Remember, if you're not ready, to go ahead and hit pause. Now, I can't do 9 divided by 15, but I can reduce that. They're both divisible by 3, so when I reduce the fraction, it's 3 over 5. I'm then going to do the square root of 18 divided by the square root of 2, which is the square root of 9, because 18 divided by 2 is 9. 9 breaks down to 3 times 3, so I have a pair of 3's, which will join this 3, making it 9 over 5, and there's no longer a radical because there's nobody left at home. Okay, let's look at another example like this. Let's say instead I had 4, the square root of 12, divided by 8, the square root of 2. I can't do 4 divided by 8. I know you want to say 2, but it's not. I can reduce 4 over 8, and it's 1/2. One trick that I keep this straight in my mind is 8 divided by 4 is 2. I started at the bottom, so my answer goes on the bottom. Okay? Then I'm going to do the square root of 12 divided by the square root of 2, which is the square root of 6. You can write it like this, or you could say the square root of 6 over 2, because 1 times the square root of 6 is just the square root of 6. Next example. Okay, you cannot do a plain number divided by a radical. And another rule is, in your final answer, you're never allowed to be left with a radical on the bottom. So how do we get rid of it? Well, let's think about this. The only way to get rid of the square root of 3 is if I had another 3. So I'm going to go ahead and multiply the bottom by the square root of 3. Then I have a pair of 3's. Because same times same, you just drop the radical. However, I can't just do that to the bottom. When I do the bottom, I must do the top. And that's because the square root of 3 divided by the square root of 3 is just 1. And when you multiply anything by 1, you're not really changing the problem. So it's allowed in math. Okay? So the square root of 3 times the square root of 3 is 3. And then I have 9, the square root of 3. Now I can apply my other rules that I was practicing. So plain divided by plain, 9 divided by 3 is 3, the radical of 3. Okay? So again, when you want to get rid of a radical at the bottom, you just multiply it by itself. What you do to the bottom, you must do to the top so that you're really multiplying by the number 1. Because remember, when you were younger, 2 times 1 is 2, 3 times 1 is 3. It doesn't change the number when you multiply by 1. Okay, here we go. Can't have a radical on the bottom. I'm going to go ahead and multiply by the square root of 12 over the square root of 12. Now, some people would have simplified this radical. I find it simpler just to do this step and we'll do the simplification later. So on the bottom, radical 12 times radical 12, square root of 12 times square root of 12 is just 12. And if you remember the trick we had before, when you multiply radicals, it's easier to factor them first. So I'm going to go ahead and factor them. Okay, I have a pair of 2's, which is going to join the 2 that's already outside. And then I have a pair of 3's. So 3 is going to come out, and 5's left alone, so 5 stays home. So 2 times 2 is 4, times 3 is 12. 12, the square root of 5 over 12. And then I can do 12 divided by 12, which is just 1. So my final answer is 1, the square root of 5, or you could have just said the square root of 5 because they cancel. Okay? All right, let me give you one more to try on your own. Let's say that we have 6 divided by the square root of 20. Well, let's make it a little more challenging. 6 the square root of 15. Okay? So go ahead and take a couple seconds and try this one on your own. Okay? All right. I'm going to multiply by the square root of 20 to get rid of the radical on the bottom. That leaves me with 20 on the bottom. Okay? I'm going to go ahead and factor 15. That's 3 and 5. I'm going to break down 20. That's 4 and 5. Break down the 4, 2 and 2. I have a pair of 2's that will join the 6. So 6 times 2. And I have a pair of 5's. And this 3 is by itself, so 3 stays home. So that gives me 6 times 2 is 12, times 5 is 60. So 60 to the square root of 3 over 20. I can do 60 divided by 20, which is 3 root 3. And that's division of radicals.